Hello students, good day to all. It's Yusuf sir again with the third video of lines and angles. So let us begin our today's session. So before starting our today's topic, I would like to revise what we have dealt in first and second video. In the first video, we have dealt about points and its types. Then we have dealt about lines and its types. Then we have also dealt about angles and its types. So in the second video, we have solved the problems of exercise 6.1. Now in the third video, we are going to study about transversal and parallel lines. Now what are these transversal lines, parallel lines? Then we are going to study angles related to transversal and parallel lines. So let us start our today's topic, that is transversal and parallel lines. So let's go for the first topic, that is transversal lines. So what are these transversal lines? Now let us define it first. Okay, now transversal lines, it is a line which intersect two or more lines at distinct point. What does this mean? Let us see the diagram. See, there are two diagrams here. One in one Y diagram there are parallel lines. Here in other diagram there are non-parallel lines. So in the first, see, in the parallel line what's happening. So one more line, red line, it is cutting that parallel lines. That line which is cutting those parallel lines at two different points, that line it is called as transversal line. In the second diagram also you can see that two non-parallel lines are there. Again one red line, it is cutting that lines. That line it is called as transversal line. The line which intersect two or more lines at distinct point. If you can see that these lines, they are cutting those lines at distinct point, so these lines are called as transversal line. The red line which you are able to see on the screen, they are called as transversal line. So to explain this more, I would like to show you few figures or images, you can say. Okay, so let us begin with the first image, that is this. Just observe this image. Can you identify what it is? If you have observed it, if your answer is railway track, you are absolutely right. Okay, it is also looking like a ladder also. Okay, if it is a railway track, if you can see that there these concrete poles, they are intersecting this railway track at two different points. There are many transversal lines, you can say there are many transversal lines for these railway tracks, because they are intersecting at a two different point everywhere, you can see. Okay, so this is the best example, you can say. You may take a ladder also. Okay, so second, let's go for the second example. Okay, now you can see that in the second example there are two roads and it is being intersected by one more road. That one more road which is intersecting both the roads, it is called as transversal line. See, here there are two roads and it has been intersected by one more road. That road which is intersecting both the roads, that it is called as transversal line. It is intersecting at two different points. Okay, so let's go for the next example. The next example, it is, if you can see that you might have seen at the bridges, these barricade will be there. There also you can see that there are parallel lines which have been intersected by a transversal line. These lines are called as transversal lines. These lines are transversal line which are cutting parallel lines. See, here two or more, here three parallel lines are there, right? Okay, now let's move for the third or fourth video. In this video you can see that here there is a what you call stair railings are there. Stair railings are there. It is been cut by a one more line, that is called as a transversal line. Okay, now let's move for the third bit. Okay, let's go for the next one. What are parallel lines? Okay, now next is parallel lines. Now what is this parallel line? Let us define it first. So parallel line which remain at the same distance apart over their entire length, means how long you extend it, it will remain at the same distance itself. No matter how far you extend it, you can extend it to infinite distance. Okay, it will remain at the same distance only. They will never meet. You might have studied in primary classes, so what are these parallel lines. So just see this figure. If you just see this figure, these lines are at equal distance. The distance between them is everywhere it is at an equal distance itself. Such lines you call it as a parallel lines. Let's go for few live examples. What are the example? Best example is your railway track itself, or you may take a ladder also. Okay, now next example it is, see, in the fields you might have seen this such kind of what you call lines will be there. They will be at an equal distance, so these are also called at a parallel lines itself. In the next, see, you might have seen this kind of images on the highways. Their stripes will be there to mark down the edges of the road. Okay, at the edges of the road or in the middle of the road, or to denote that it is a highway or a state highway or it is a national highway, whichever it is, they will be given there, it will be given some marking. So these are also the examples of parallel lines. Okay, next example it is, you may see a rack where you can keep your books, bags, some other things also. If you just see that between each and every rack there will be a equal distance, such kind of what you call lines you may see there. Such kind of lines you call it as a parallel lines. Okay, now let's go for the corresponding angles. Now angles related to the transversal and parallel lines. So what is this corresponding angles? Now let us define it first. So the angle which occupy the same relative position at each intersection when a straight line crosses two others. So what is this? What is it saying? Just see the diagram. When a straight line crosses, what happened? Two other lines. Means if you just see this figure, a line, it is crossing two other lines. Now two other lines, these two are two other lines. It is crossing one line, it is crossing two other lines. What is happening there? Their transversal is created. Now when this happens, what happens? They occupy the same relative positions. Now what is the same relative positions? Now just see this figure. Now shall I zoom it? Okay, now here you can see that this angle, it is occupying the relative position. This angle, it is occupying the same relative position of this angle. So these angles, such angles are called as corresponding angles. Okay, if two lines are parallel, then corresponding angles are equal. See, these two lines, if they are parallel, then only these corresponding angles will be equal. Okay, now one more corresponding angle we can, in this figure, can you identify which is that? In this figure you can say that this angle is also corresponding angle of this angle. Okay, so this is also corresponding because it is also occupying the same relative position, so it is also corresponding angle. So we have got one more figure here. Now before that I would like to say one more line, that is, these are angles in the matching corners. See, in the simple words you can say matching corners angles. See, corresponding angles are nothing but the matching corner angles. Okay, in short it is just to understand. Okay, so next figure you can see that this is the next figure. Now here in this figure, can you identify the matching corners? Let us identify first one by one. Now which is the matching corner for angle 1? So for angle 1, matching corner is angle 5. So let us go for one more. So which is the matching corner for angle 2? For angle 2, angle 6 is the matching corner. Which is the matching corner for angle 3? For angle 3, matching corner is angle 7. For angle 4, which is the matching corner? For angle 4, matching corner it is angle 8. See, these are the matching corner, means corresponding angles. So we can write that, what we can write here, angle 1 and angle 5 are corresponding angles, angle 2 and angle 6 are corresponding angles, angle 4 and angle 8 are corresponding angles, and angle 3 and angle 7 are corresponding angles. Okay, so let's move for the next bit, that is alternate interior angles. So what are these alternate interior angles? So let us define it first. So the angles that are formed on the opposite side of transversal and inside the two lines are alternate interior angles. Now what does this mean? Let us understand it by the help of a diagram. First I will zoom this diagram first so that you can understand it easily. So let's go for the diagram. In this diagram you can see that which is the transversal line, the blue line which is vertically. Here can see that this line, it is a transversal line. Okay, now the angles found opposite to the, which are opposite in the transversal line. So this angle, the angle x, you can see that is also equal to this angle. They are on the either side, opposite side of the transversal, means one is this side, other is this side. Okay, these angles are alternate interior angle which are inside the parallel. See, which is a parallel, which are the parallel lines here? These two lines are parallel lines, and inside those, which are those angles? These two angles are inside. And similarly these two angles are also angle y and angle y. These are also alternate interior angles. These alternate interior angles are equal only when that the two lines are parallel. Remember this one. This is when the parallel lines arises, alternate interior angles are always equal. Okay, let's go for the second diagram. Okay, now which is the second diagram here? Now just see, can you identify which are the alternate interior angles in this diagram? See, angle 3 and angle 6 are alternate interior angles. Angle 4 and angle 5 are alternate interior angles. Okay, just I'll change the color of this. Okay, now if you just see, angle 4 and angle 5 are alternate interior angles. Now remember this one, they are inside the parallels, therefore they are interior angles. We are not taking any outside angle. Okay, now similar, that's what we are going to we have written here. Angle 4 and angle 5 are alternate interior angles, as well as angle 3 and angle 6 are alternate interior angles. So let us move for the next bit, that is alternate exterior angles. What are these alternate exterior angles? So let us define it first. The angles that are formed on the opposite sides of transversal and outside the two lines are alternate exterior angles. So we have studied that if it was interior angles, if they were inside the parallels, then if they are outside the two lines, then they are exterior angle. Let us study by the diagram. If you see the diagram here, now I will just zoom it, what you are able to see it here. Now just see the diagram. Now the angles which are outside the parallel, means outside the lines, see, these two are alternate exterior angles. See, 134, it is equal to 134, they are alternate exterior angles. Similarly, what you can say, one more pair it is there, that is 46, it is equal to 46. They are also alternate exterior pair of angles. Okay, so this is what the alternate exterior pair of angles are. Now can you identify which are the alternate exterior pair in this diagram? Just look. Now here these cannot be alternate exterior. Why? Because they are inside the lines, so they cannot be alternate exterior. So alternate exterior angles are angle 2 and angle 7, and one more pair it is angle 1 and angle 8 are exterior pair of alternate angles. So we have written that only 1 and angle 8 and 2 and angle 7 are alternate exterior angles. Okay, so let's move for the next bit, that is, let's move for the next bit. Okay, so next is interior angles on the same side of transversal. What are these interior angles? See, interior means which are inside. So which are inside means if there are parallel lines, the angle which lie inside the lines, that are called as what? Interior angles on the same side of transversal. Which are those interior angles? Angle 4 and angle 6 and angle 3 and angle 5 are on the same side of transversal. Now this is the transversal line. On the same side angle 4 and angle 6 is also there, and on the same side angle 3 and angle 5 is also there. So these are what? Angles on the same side of transversal. Which angles? Interior angles. They are also known as consecutive interior angles or allied angles or co-interior angles. So many names it has. What are those names? Consecutive interior angles or allied angles or co-interior angles. These angles are called as, these co-interior angle, allied angle, or consecutive interior angles. Okay, so angles on the same side of, this is all about same side of transversal interior angles. Remember this one because they are inside. Okay, angle 4, angle 6, and one more pair it is angle 3 and angle 5 because they are on the same side. Okay, so let's move for the next bit, that is we have studied about this. Now this is axioms. What are those axioms? Let's study it one by one. So axiom 1 says, what axiom 1, that is 6.3. Axiom 6.3 says, if a transversal intersect two parallel lines, then each pair of corresponding angles is equal. We have studied it. If the lines were parallel, the corresponding angles will be equal. So I have shown you. Okay, so remember this one. If there are parallel lines, then their corresponding angles will be always equal. Remember, this is axiom. We have to, their axioms are nothing but true statements, you can say. Okay, this is what axiom 6.3 says. If the transversal intersect two parallel lines, then each pair of corresponding angle is equal. Means if you see the second figure, so angle B, it is equal to angle F, then which angle is again equal? Angle A is equal to angle E, then again angle C, it is equal to angle G, then again angle D, it is equal to angle H. See, these are a corresponding pair of angles. They are equal only when the pair of lines are parallel. Okay, now let's move for the next axiom, that is axiom 6.4. What does it say? If a transversal intersect two lines such that the pair of corresponding angle is equal, you can say reciprocal of 6.3 it is. Now we have studied that if transversal intersect two parallel, then each pair of corresponding angle is equal. Similarly, 6.4 says, if transversal intersect lines such that the pair of corresponding angles are equal, then two lines are parallel. What does this mean? This is reciprocal, you can say ulta. If corresponding angles are equal, then what you can say, these, if all the corresponding angles they are equal, then you can say that the pair of line is parallel. It is reciprocal of x 6.3. Okay, now let's move for the next bit, that is theorems we have got. Now here we are going to just define those theorems. I will explain it, but for deriving it is not there. Just we are going to just understand what is the theorem say, and I will explain you how it is. Okay, now first theorem says, it is first theorem we have derived it. Now 6.2 theorem says, if a transversal intersect two parallel lines, then each pair of alternate interior angle is equal. You have to remember this one. What it is saying, if a transversal intersect two parallel lines, then each pair of alternate interior angle is equal. How they are equal? See, there are here, say two parallel lines are there and transversal it is intersecting. Okay, now if you just see, now suppose you know that the linear pair angle it is 180 degrees. Okay, so x plus y it is equal to 180 degree. Okay, now similarly here if we know that alternate angles are equal for parallel lines, and that's what we have wanted to prove. Okay, so here angle x it is equal to angle x. Okay, this is what alternate angles are. So they are equal when the parallel lines are there. So remember this one. What if a transversal intersect two parallel lines, then each pair of alternate interior angle are equal. They are equal only when the parallel lines are there. Okay, so remember this one. Angle x it is equal to angle x, that is alternate interior angle, and angle y it is also equal to angle y. Now let's move for the next theorem, that is what 6.3. What does this 6.3? If a transversal intersect two lines such that the pair of alternate interior angle is equal. Now just a reciprocal of 6.2. 6.2 said if transversal intersect parallel lines, then each pair of alternate angle is equal. Now if it is reverse, now if transversal intersect two lines such that the pair of alternate angles are equal, then the two lines are parallel. Reciprocal of these two. See, if it was alternate angles are equal, then the lines are parallel. That is what the second theorem say. If alternate angles are equal, the lines are parallel. If lines are parallel, alternate angles are equal. Remember this one. Okay, now let's move for the next theorem, that is okay, let's move for the next theorem. What does that theorem say? So theorem says, if a transversal intersect two parallel lines, then each pair of interior angles on the same side of transversal is supplementary. What is this supplementary? Supplementary means sum of two angles is equal to 180 degree, then it is supplementary. So what does it say? Supplementary means, see here what is I saying, if transversal intersect two parallel lines, each pair of interior angles. Now which are those interior angles here? See, interior angles on the same side of transversal. So these angles are supplementary. How? Because this angle it is equal to this angle. Now we know that these are a linear pair. This plus this is equal to 180 degree. Now I will just show it once again. Now see, now this plus this is equal to 180 degree, we know. Okay, now what is happening? Angle 1 is equal to angle phi. This is equal to angle phi. Again, if angle phi becomes angle 1, so these two add, if you add up, again it will be equal to 180 degrees. So that is equal to supplementary. So therefore you are going to say that if transversal intersect two parallel lines, then each pair of interior angles on the same side of transversal is supplementary. So next we are going to write theorem 6.5. What does that theorem 6.5 says? It is raised to reversal. If a transversal intersect two lines such that the pair of interior angles on the same side of transversal is supplementary. Now what does it say? What does that mean? Same. If two angles are supplementary, interior angles on the same side of transversal are supplementary, then the lines are parallel. They are 6.2 and 6.3 are, you can say, transposes of each other, means reciprocals. Similarly 6.4 and 6.5 are reciprocals of each other. Transversal, if transversal intersect two parallel lines, then each pair of interior angles on the same side of transversal is supplementary. If they are supplementary angles on the same side of transversal, then they are parallel lines. You have to remember this one. Okay, this is what this theorem says. Okay, now let's move for the lines parallel to the same line. What does this mean? So lines parallel to the same line. So let you just observe the figure. If line P is parallel to Q and Q is parallel to R, then you can say that line P is parallel to R. Now just see this angle line P. This line P, if it is parallel to Q, if it is parallel to Q, and Q is parallel to what? R. Now we can say that this R is parallel to what? Line P. This is what the parallel line say. So P is parallel to Q, Q is parallel to R, therefore P is parallel to R, you can say. Okay, now that's what this statement is. So you are going to write lines which are parallel to the same line are parallel to each other. So you have to remember this. The lines which are parallel to the same line, P is also parallel to Q, R is also parallel to Q, therefore P is also parallel to R. You have to remember this one. P parallel to Q, R is also parallel to Q, therefore R is parallel to P. You are going to write it. Okay, so this is all about parallel lines on the same side of transversal. Okay, this completes your third video of lines and angles, that is transversal and parallel lines. In the next video we are going to solve exercise 6.2. Third video